Hi, welcome to UTA Planetarium live star stream. My name is Levent Gürdemir, UTA Planetarium Director, and here in the office, Jim Bader, Program Coordinator with me. Hello, Jim.
Hey, how's it going?
It's another beautiful Wednesday.
Oh, it
I
is so
cannot
nice. This
complain.
week has been great.
And I think we have some big events coming up, right?
Yeah, we have several things. So we have some announcements for sure, Levin. I don't know if you want to cover the announcements. Two pretty important things. Hopefully, things that everybody's excited to hear or know about.
The next big event is going to be the lunar eclipse. Almost total, but still partial lunar eclipse coming up on Friday morning. We'll talk about it later today in the stream. And also another big thing we would like to announce is the reopening of the planetarium to public. We already are doing in-person field trips. We started in October, but public, we get a lot of calls and emails and social media posts. Sorry, every time we say, well, wait, check us our website for the updates and maybe next month. And that time is now here. So December 4th is going to be the first day of public shows. We are starting with Saturday only, and we will extend it to Sundays as needed in the future. So you have to just bear with us that there's a lot of COVID restrictions involved, cleaning and scheduling. They're all challenges. But finally, you will be able to visit the one of the most impressive and the largest planetarium theater in the state.
I am so excited and
I know
a
because you
little
love public
nervous.
shows, you love people, having people in the planetarium theater, right?
Yeah, I don't know. We don't have the show announcements just yet, but we will post those on social media as soon as we are ready to hand them over to everyone.
Great.
Which is pretty exciting, I think. For me, anyway. All right.
What you have?
Yeah, okay. So this show is called Ask an Astronomer, and we don't always, uh, just answer astronomy questions on here. But we've had a couple. Thank you to Lamia. So I want to a big shout out to Lamia for assisting in this. This goes out to everybody. If you're watching this, whether you're watching it weeks after this aired live, if you have astronomy questions, pressing, interesting, new news questions, send them to us. You can just send us a message. You can drop a comment in this video and any other video. We keep track of these, and we'll address it, right, Levin?
Exactly.
Yeah, astronomy,
social
space
media
related.
meant to be interactive. So this is different than television. In the television, you cannot just interact with us. But in here, we would like to talk to you.
Speaking of television, can we say
Tomorrow
what?
Jim and I are on Good Morning Texas tomorrow morning.
Yes.
Talking about, guess what? Lunar eclipse.
Couldn't be the lunar eclipse. Could be the
Friday
blood.
mornings, lunar eclipse.
When we say Friday morning, it's like Friday really, really early morning. So
It is.
Thursday night.
Well, the main event or the totality, not totality actually, but it's going to be happening around 3 a.m. The entire event will be starting from like 1 a.m. after midnight. So if you don't have any commitment for the next day morning, you can perhaps stay awake and watch it.
Should we go ahead and just show them what they would expect to see and what time they want to see it?
All right.
Yeah, let me pull myself out of the way here.
Sounds great. So this is going to be the sky.
1 a.m.
Like 1 a.m.
Yeah.
Okay, Thursday morning. I mean the Friday morning.
Yeah.
Thursday late evening, Friday morning. Here is the one of my favorite astronomical objects. This is Pleiades, seven sisters, seven bright stars. It's a open star cluster. Maybe perhaps we can take a look at it later. And also there is a very the winter's favorite constellation, Orion, I see. So things are coming up great. You can also enjoy seeing those. But here is the moon. The moon is, we don't need to give any direction, I guess, because it is the brightest thing in the sky. So
I'm going to zoom in on it just a little bit.
You just need to look up in the sky.
Just a quick zoom in. It should be popping right back.
All right. So this looks normal, around 1. So let's go forward in time. How it is gonna look a little later. Oh, did you see? It started developing a red spot starting from the top, and then it migrates downwards. All right, let's continue. So, and this side is getting darker and darker as the red tint migrates down, pretty much eating up the entire moon. And by 3 a.m., it will just leave a bright crescent corner over here. This side still will be visible and brighter than all other regions, and probably the top side will disappear completely. So this is what we call lunar eclipse.
I brightened it up just a little bit so that you could see it. Kind of disappeared.
Yeah, it's not going to be this red, this bright red. It's going to be very dark but noticeably red. And the media calls this type of moon bloody moon. Would you agree, Jim, with that?
Yeah, that's all the time. They call it the blood moon. Not a lot of blood up there, right?
No, I hope not. So yeah, that's I take it as a very violent term, blood moon. I don't like it either, because this is not a scientific term. This is just a media term, like supermoon, for example, too. There is no supermoon in astronomy texts.
Yeah, it doesn't get a cape and underpants.
It is just made up terms. So what's going on here is the first lunar eclipse is. That happens when the moon goes behind Earth and enters into its shadow. Pretty much the moon hides from the sunlight. So in that case, the moon loses the sunlight, and because it loses the light, it turns into dark object in the sky, which we think it disappears. But the red color is actually, there is some other physics going on behind this red color.
We don't want to spoil too much of the physics stuff, right?
No, we don't. But this is easy.
Okay.
This one is pretty easy, because if anybody familiar with rainbows in the sky, are you familiar with rainbows in the sky, Jim?
I definitely am. Yeah.
Like the sunlight, the air molecules, especially the humidity in the air, spreads the light into colors like red, blue, and in the middle orange. All 7 colors. That happens because when light goes through a dense medium, all the other colors, different colors, are treated differently, and actually they bend differently at different angles or different amounts. Red gets the bent most, and the blue is the least. For that reason, uh, the when the moon is in the shadow, the red color actually is diverted and bent into onto the moon's surface, and that's why we see the moon red.
Well, it looks beautiful. I think
Mhm.
I think they should just stop calling it the blood moon and just let this moon this weekend just be known as the beaver moon.
Yes.
That's I mean that's the almanac name.
Yeah,
Sorry.
beaver moon.
Also a silly name.
Yeah, beaver moon is the name of the full moon in November, according to the Farmer's Almanac.
I gotta say the names that they come up in the Farmer's Almanac are ridiculous. Some of them, Worm Moon,
Yeah, this
uh,
is the time that
Beaver's
beavers
Moon.
return to their cabinets.
Oh, is that really?
I mean, that's what they say.
Okay, okay. And that also makes sense that that's what they say.
I mean, you can read the reasoning behind even every given farmer's almanac name, and this is directly related to the farmers' events. And in that time of the year, they say the beavers are returning to their cabinets and they are starting to eat, the stored food over the summer, etc. Um, so flower moon, for example, I think it was like March or
Yeah, that makes sense.
yeah, I
May
mean,
or
in the spring, there's a flower
something.
moon when the flowers start blooming, etc. And wolf moon I think it was February, wolf moon.
I like
The
that.
wolves howl, and that's how they came up with the names. So, yeah, beaver moon, full moon. But let me talk about a little bit all the misconceptions given on the media. And the one
Oh,
biggest misconception is the headlines read, very rare event happens in only once in 600 years, or some says like 1,000 years, the longest duration, the longest lunar eclipse. Well, yes, I mean, in fact, that is true. This is the one of the long-taking lunar eclipses, but lunar eclipses take long time anyway. They last somewhere between like 2 to 6 hours. Um, so for that reason, the length being 20, 30 minutes longer or shorter is not going to make huge impact for the event. So to me, it is not very important, not significant, and I don't care about the duration of the total or a partial lunar eclipse at all. Um, Another misconception given was that one article I seen said, "Oh, this lunar eclipse coincides with the full moon in November." Really? Mm.
we should definitely cover why that's so funny on Friday, because
Well,
that is
when I
something
checked
else.
the previous full moon, the previous lunar eclipse, that also coincided with full moon. And I checked one before that also coincided with full moon. And I checked like 10 past and 15 past lunar eclipses. They all coincided with the full moon. The fact is, the lunar eclipses only happen during the full moon. So
Well,
there is no coincidence here.
I think what's important, and I just want to apologize for laughing as much as I did at that, because we are an educational institution and our job is to teach. So when you bring statements like that to us, I should not be laughing. I
Mhm.
should be um excited to, and when we are both of us, I'm sure, excited to explain why that
Yeah, and
is.
and most of the time, these type of misconceptions are written not with the bad intention, bad
Yeah.
purpose. They are just written by somebody who doesn't have enough expertise in the field. So maybe they hear something and they interpret wrongly and something like that. So no,
Yeah.
certainly, we are not thinking that they had some bad intention to do it. But this is misconception. This is our job to correct, right?
Definitely.
That's why we say we have expertise in the field. So yeah, there is no bloody moon or blood moon. The moon turns red because the Earth's air refracts light, and the red gets the moon. That's it.
Would be really beautiful though, for sure. We have some I guess a quick comment from Lamia, who said that unfortunately I will not be able to see it, and this is a North American lunar eclipse, if I'm not
Yes.
mistaken.
Yes, not everybody sees the same thing around the world. Especially lunar eclipses are pretty wide to everyone, unlike solar eclipses, though. But of course, you have to catch the lunar eclipse time during the night time. If it is daytime in your country or location, then yeah, you have to miss it
That's
unless you have ability to travel in advance. But there's actually another good total solar eclipse is coming very soon, December 4.
oh,
Total
do you know
solar
where
eclipse.
that one's gonna be at?
Unfortunately, not around here.
I
Not
mean, I
visible
did know
from
that,
North
but
America. Not visible from the most of the world. You have to travel to either the very south
poles.
tip of Africa or Antarctica, which nobody lives.
Yeah.
Then you can get to see the total solar eclipse.
Well, those are very interesting.
Mm-hmm.
Very interesting. All right, we should jump into this question that we got from
Yes.
a viewer,
Uh-huh.
Lamia. You can take credit for these if you like. Kurt, thanks for joining us. He's also interesting comment there, Kurt. Anyway, let's get to this question. So the question said, I have recently seen a photo of Saturn's North Pole, which had something like a hexagon shape. I know Saturn is a gaseous planet, so I could not understand how it could
Mm-hmm.
have such a geometrical shape. Can you please
Yes.
elaborate? I guess I can stop there and let you elaborate just a little bit on that. Here's the beautiful picture of
Mm-hmm.
Saturn's
Yeah.
hexagonal.
This was first noticed by Voyager 1, and then later Cassini spacecraft
Mhm.
took amazing pictures and also a video showing the rotation of this entire hexagon. Yeah, hexagon shape is something we don't normally see in any astronomical object. Every planets and stars tend to be round objects, and also even the hurricanes and every like the weather related activity on the surface of planets are most of the time circular, or at least symmetrical. This is a different shape, and that's thought to be big. We don't know exactly the reason. We cannot explain the exact the dynamics over there because we don't have enough data about the interiors of these
Yeah.
planets. We can only model, and according to the models, there are some strong vortex forces and jet streams. They push the storm hurricane into the hexagon shape, and this entire hexagon is also rotating. That's pretty interesting.
Yeah, I thought it was really interesting that in reading about it, the hexagon and then the little storm in the center, which I
Mm-hmm.
can kind of pull this down so that everyone can see it.
Yeah.
But the little storm in the center, and by little I mean it's humongous.
Mm-hmm.
They rotate the same way, but most of the little storms inside of this hexagon actually rotate the opposite way. Um, there's so much about this storm that is really interesting, and
Mm-hmm.
also it's another one of those things that most scientists just don't have a lot of data to
Mm-hmm.
know
Yeah.
why.
From these sources, I think that Jupiter is the researched the most because there are a lot of hurricanes and the storm regions, especially showing up on the surface of the Jupiter, including Great Red Spot. So
Yeah, we
these are
have
pretty difficult to explain, and all the fluid dynamics and again the interior, the convection zones and everything, they play a critical role in what's showing up on the surface. We can only see the
yeah.
features showing up on the surface, and now we can just model or theorize what can be going on inside that causes the things on the surface.
One of the research papers I was reading from some researchers at Harvard were saying that they hypothesized that the storm was interacting with currents thousands of miles below the surface of what we're seeing. So that this is a super deep thing,
Mm-hmm.
and we can't see that, right? That's not a thing we can.
Yeah.
It's wild for sure. They thought it was a Saturn only thing,
Mhm.
but turns out that Jupiter has a similar thing. Jupiter's south pole also has a geometric shape here, not
Mhm.
quite as interesting, but a bit of a pentagon. Jupiter's north pole has
Mhm.
even more storms. This looks like some kind of crazy ritual. This is crazy looking.
It's like the combination of swirly regions, hurricane regions, and they are all being combined to just make a gigantic one.
Yeah, it's just like a huge maelstrom in the middle,
Hmm.
and that's really what a lot of people would say and hypothesize. On Earth,
Hmm.
hurricanes they hit land and they stop,
Yeah.
but there's no land on these, so they continue and then they get to the poles just like they
Mm.
would here on Earth. Um, and then if you're lucky, like at Jupiter, they're surrounded by these anticyclonic rings that stop them from merging together, so they
Mm.
just bunch up down there.
So apparently those planets have plenty of energies.
Yeah.
They are never like quiet and boring. When we look into detail, they may look very boring on the telescopes, but when we look close up, especially sending a spacecraft like Cassini or Juno or many others, Voyagers, when they get close, we realize the planets are not boring. Too much thing going on the surface.
Yeah, not nearly as boring as maybe previously thought. And I guess if you're on Earth, you don't see it.
Uh-huh.
So I don't know, kind of wild.
I mean, even if we look at our planet, it looks boring from outside, but there is a lot of going on other than the human activity. Just, if you are going under the sea, in the bottom of the oceans, there are different things, even these uh, lava related activities. We have volcanoes, we have like tornadoes going on, hurricanes going on, strong winds, some places, rain, snow, right?
Yeah.
The rivers flow, sometimes flood. We have too much going on, even including our own planet.
Way too much. We have some comments about the story, which I think are a good time to jump into. Janet says hexagon, wow, cool. And then Lamia asks, aren't hurricanes normally circular? They definitely are. And
Mhm.
you can see most circular behind me, right? Most of this
Mhm.
stuff is circular here.
Yeah.
Um,
I-
the hexagon is interesting, though.
we think that when there is a force developing and the force is acting each direction, each distance the same way, the event should be circular or spherical in some cases. And that's why sometimes people say, why the planets are not squares or triangulars? They're all circular or they are spherical. The reason is the gravity is acting the same amount in each side of the planet. So that means it is everywhere is treated equally, and there's only one geometrical shape to explain this, and that's a spherical. So the hurricanes that we are thinking the same thing. But if there is anything out of ordinary other than circle, that means there are some external forces acting on. Maybe there are some limitations. Maybe like there are some boundaries that they cannot exceed by their force. So in that case, you see different shapes. Most of the time we see ellipses. Those are pretty much squished circles. And if there are some boundaries in some mediums, they can be squished or they may be rotating fast. Rotation makes another external force,
Mm-hmm.
centrifugal force, right? Centripetal force, and then they elongate things. So um, mostly should be circular, but in the existence of external forces, it can be some other shape too.
Yeah, definitely. All right. We have one more question, Levant, which we can
Mm-hmm.
kind of touch on. We don't have to go too detailed in. It's a kind of straightforward question. And this is why what color is the sky at night, and why does
Mm-hmm.
it often seem blue? And the I guess from most sources, the easy answer for this question is
Mm-hmm.
that the sky is black, but it's just our perception, the way our eyes work, right? Because there's huge spectrum of color,
Mm-hmm.
and we can't see most of the colors. And in order to see colors, humans they need a lot of
Mhm.
light.
Well, you are apparently going into the very technical thing. My probably I would stick with the easiest answer to black. But what you say is true, and the sky, the atmosphere. First, it has two things. It has the scattered light from the sun, even though the night side of the Earth is not facing the sun, and technically we say we are not getting any sunlight, but there is a little bit scattered light um, leaking out from the bright side, but it is not enough for us to be able to see. The second thing is the atmosphere is also warm, not as warm as the other side, but still that the warmth is also leaking to the night side. That's why we don't have actually a big difference between in the temperatures between the night side and the day side. Yeah, you may argue that yeah it was like 40-degree difference. Uh, 40 degrees is difference is not much, because if you look at the moon doesn't have any air. The night side and the bright side differences are about 300 degrees, 400 degrees. And if you look at the Mercury, you see the same thing. So if we didn't have air around Earth, we would freeze overnight and melt during the daytime.
Sounds
So
exciting.
because of this the warmth, it also generates some the energy, and it may be translated into some color. But after all, this type of energy is too weak that our eyes cannot see. Like just like we cannot see very dim stars because they are not sending enough energy to our retinas to make sense. So there is like a low limit for our retina to be able to recognize an object. And if there is not enough light, then it is not seen to us. That doesn't mean it doesn't exist. And that's what telescopes do. They magnify, they collect more light, they increase the brightness of the object, and we are able to see.
Yeah.
So
Behind you, I put some examples
yeah,
of this
if
is
we,
cameras see
mhm,
blue. You can see hues of
mhm,
blue here, and
yeah,
here's Rayleigh scattering
mhm,
from moon
yeah.
light.
Yeah, we can see like this is all magnified or amplitude, uh, the scattered blue light. So why sky is blue? That's another question.
That's I mean
Why
that kind of
blue?
covered in similar. What do we say? We say
Yeah,
Rayleigh
like the
scattering.
same thing. Like if you think about rainbow, the atmosphere is treating the light, every different color differently. So the light is scattered, the light is refracted, and according to the density and the dynamics and the chemical composition of the atmosphere, blue light is the one mostly making to the light. Not only the atmosphere is not only transmitting the blue light, it is transmitting all colors, but the blue as most. That's why the
Yeah.
sky looks blue.
Yep. All right. We have some additional comments. Looks like
Mhm.
let me pop on here. Livia, you're very welcome to answer the question. And then Kurt's back. It's been a while since Kurt is.
Mhm.
I feel like, but he says this is interesting. I recently bought a 600 millimeter lens for my Nikon. Any recommendations for a tracking mount? I I don't have any experience with tracking mount astrophotography, so I can't comment. I don't know about you, Levent.
Well, there are several tracking mounts. I would stick with the known brand names like Orion, Celestron, Meade,
I couldn't go wrong.
yeah, there are maybe like large variety of those. Reading the reviews will be the most helpful, because some the tracking mounts are having plastic gears. Usually, those are on the cheap side, and the most problematic ones. You need the solid rings and the motors. And I know the tracking mount can be jumping up to
Those are,
thousands of dollars.
just looking, those are
I
very
don't
not
think there
cheap.
is enough reason to spend too much money on that, but yeah, spending on too little is also not going to work as right. Um, so Nikon cameras are heavy. The mounts apparently needs to be very stabilized, and if you need to get one with these like the weights
Oh,
on the other
counter.
side, the German mount.
Yeah, those
It the fork mounts are hard to find actually. My favorite the telescope mounts are fork mounts because fork mounts you do not need to balance your telescope a lot. Just a simple sometimes like if you even need a weight, a simple weight is going to be just enough. But yeah, I would stay away from spending too much money. But again, don't be on the too cheap side. Maybe somewhere in the middle, and stick with the brand name who have good reviews on.
yeah. 600 millimeter lens also. That's got to be some weight. So
Yeah, yeah, it's a heavy machine. It's
Nikon
a
plus a big
heavy
old
camera.
lens. Oh well. Well, Levent, I think it's important in time for you to tease what we're going to talk about on Friday.
Hmm. Yes, Friday we are going to talk about the lunar eclipse. We'll explain from the astronomy side why lunar eclipses happen, how they happen, and how frequently they happen. We'll explain that with all the drawings and visuals. We would like
Need
to see you on YouTube
need
at
visuals.
noon
Yeah.
Friday.
All right. Well, I think that does it for this week's episode. Thank you, everybody who
All right,
watched.
great. See you on Friday. Bye bye.
Bye bye.